Hello, welcome to Sunday Call. Today we are going to solve the day 30 of August LeetCode challenge. So today's problem name is largest component size by common factor. So basically, if you read the problem statement, it's saying that we will be given one array of integer of array. In that you can think each of the number of that array as a node, and we need to find the largest component size. Okay, by common factor. What that means? So if you check the first example, right? So in the first example, you can see that we have 4 nodes, right? 4, 6, 15 and 35, okay? And in that case, I can see that 4 and 6 has common divisible. Again, 6 and 15 has common divisible because we can divide 6 by 3 and 15 also can be divided by 3, okay? Similarly, 15 and 35 have also common divisible, that is 5. 15 also divisible by 5 and 35 is also divisible by 5, okay? So that means we can find only one set, and since all the 4 nodes are connected with each other, then in this case we can return our output as 4, right? But if you check the second example, right, you can see that here our input is 20, 50, 9 and 63, okay? So we can see that 20 and 50 are divisible by 2, right? So this is one set, and again 9 and 63 is divisible by 9, so this is another set, but these two are disjoint set, right? So there is no link between these two sets. So in this scenario, we need to pick up that set which has maximum number of nodes covered, right? So in this case, both have equal number of nodes, so we can return 2, right? Since both disjoint sets have similar number of nodes, okay? So let's try to see the third example also. For this example also, that we can see, if you draw the graph like this, we can get a complex graph like this. But again, we can see that all the nodes are interconnected, right? So in that case, we can return 8, right? Since all the nodes are interconnected, so there is only one set, there is no multiple disjoint sets, okay? So this is the problem statement and we need to solve it, okay? So how we can solve it? So basically, you understand that we need to at first we need to build one logic using which we can find that it's a common, and these two nodes have common parents, so basically parent-child kind of relationship. Okay, we are going to solve it using union and find algorithm. This is one of the common and popular algorithms. So at first we are going to take two array, right? One will be the parent array, in which we are going to store the parent for a corresponding node, and another will be rank array, right? In this array we are going to store the rank of corresponding nodes, okay? So we are going to declare two arrays. So at first we will try to identify the maximum number in the given array, right? So it's 63 here. So that means we need to consider all the nodes till 0 to 63. So initially parent array size will be 63 plus 1, since we are considering from 0. So it will be till 64, and again rank array will be also for till 64 only, right? And since initially all the 4 nodes will be disjoint, right? So what that means? So initially 20, 50 and 9 all are disjoint. That means there is no relation between them initially, okay? So initially all the parents will be, so it will point, its parent will be this node also only, right? So suppose 0's parent will be 0, 1's parent will be 1, 2's parent will be 2, like this, okay? Similarly for 63 also, 63's parent will be 63 only, okay? And rank will be initially 0 for all the nodes, okay? So now this will be our initial position before we will design our algorithm, okay? Now what we will do, we will pick one number from the given array, right? So we can see my first number is 20, okay? So we will pick one number and we will try to identify all the possible number which can be divisible by other numbers, right? So if we start with 20, right? So 20 can be divisible by 2, yeah, correct, it can be divisible by 2, or it can be divisible by 10 also, right? So the possible combination that we can divide 20 by 4 also, right? Similarly we can divide 20 by 5 also. Similarly we can divide 20 by 10 also, right? So 20 can be divisible by all these 4 numbers, right? So but since we are considering these two, so suppose if we are considering till 4, then we can consider these two other portion also, right? So what we will do, okay, so what we will do, we will initially take the first number, right, 20, then we will run one for loop to identify all these number, right? So all the number which can divide 20, okay? But we need to consider till the square root value, right? Because if we consider 4, then we can do it for 5 and 10 also using 2 and 4, right? So we will run our for loop till the value of square root value of 20. That means square root of 20 is 4 point something. So we will run our loop starting from 2 to 4. See, we don't need to consider 1 because every number is divisible by 1. So we need to start from 2 only. So we will start from 2 and we will run our for loop up to the square root of 20. That is 4.5 something. That's the integer value. It will be 4 only, right? So after that, so that means 20 can be divisible by either 2 or 4. So again, if we then we will try to we will call our union methods, right? So in union methods, we will try to identify root or parent of these two nodes, whatever these two nodes, and then we will try to see that is this we will try to build the parent-child relationship between those two nodes to create separate groups or disjoint sets. Okay. So initially, for 20, I can found there is two possible values, 2 and 4, right? Again, so we are going to run our union or call our union method for twice. One will be for 20 and 2, another will be for 20 and 10, because we need to consider both 10 and 5 also, right? Similarly, for 4, we are going to call union method once with 20 and 4, another time it will be 20 and 5. Okay, so all these 4 possible combination, right? So now I will check. Okay, so for first case, right, my value is 20 and 2. These are the two nodes. We need to identify that is there any grouping possible or not, right? So I will check. I will come. So I will suppose it's u value, right, and it's v. These two nodes, right? So for u nodes, I will go to my parent and I will check what is the parent of u, means 20. So initially it will be 20 only, right? So I can see that for 20, my parent will be 20 only. Again, for 2, again I will see initially parent of 2 will be 2. So in this case, I can see that both these I can identify these are the two parents for these two corresponding nodes. So now we need to try to group it, right? So how we can group it? So if it is at separate groups, then we can put them in a single group. Okay, so to do the same, we need to check that. Okay, so now we will check our rank array, right? So for I will check for 20, my rank is 0, and for 2, my rank is also 0, right? So this means these two have same ranks. So if it has same rank, then we can make anything, right? So we can either make 20 the parent of 2, or we can make 2 is the parent of 20, right? So this is how the union and find works, right? So we can choose any of the one option, right? So probably we choose like this, right? 20 will be the parent of 10, 2 will be the parent of 20, right? And in this case, rank of 2 will be, since it's a parent, so rank will be plus 1. So initially it was 0, now it will become 1, but for 20 it will remain 0, right? So again, I will update my, so suppose this is my 20 and my parent 20, parent of 20 will become now 2, since it's absolute parent, right? So it will be 2, and rank will be, for rank for 2 will be my 1. Initially it was 0, now it will be 1. Okay, so this is how it will work. Now again we will try to find it for again 20 and 10. So again my next is 20 and 10. So now again I will check the parent of 20, right? So for parent of 20 I can see it's already 2, right? So again I will find the parent. Initially it was 20, but we updated it as 2, right? And for 10 it will be 10 only, right? So again we will check the rank. Since both parents are not equal, then we can group them, right? So to group them, to identify its absolute parent, we are going to use the rank. Okay, so using rank we can find that parent rank of 2 is 1, right? Initially it was 0, but it has one child, right? So that is 1. And in case of 10 the rank is 0. So that means 2 should be the absolute parent of 10. Okay, so this is how it will look. So 10 should again be point to 2, and 20 will also be point to 2, right? Now again we will find for 20 and probably 20 and 4. So if you do that, you will see, you can see that again it will be like this, right? For 4 also it will be 2, right? 2 will be our parent, since 2 rank is greater. Okay, and 20 is always already there. So similarly we need to find for 20 and 5. So for 20 and 5 it will be like this only, right? So again 5 2 will be the 5 of a parent of 5, right? So our array will look like this. Okay, so after first iteration for 20, it will our tree, actual tree or set will look like this, right? So 2 and 2 will be the absolute parent, and all this node will be its child, right? Okay, so now after that we will go move further, right? So now our next number is 50. We will check it for 50 again. So for 50 we need to check, so we need to take square root value, right? For square root value is 7, so I will check. So 50 is divisible by 2, right? So we need to check for 50 and 2. Again 50 is not divisible by 3, not by 4, and it's divisible by 5, right? So again we need to consider 50 and 5. So basically there should be two combination. One is 55, another one is be 50 and 10, and another one here it will be 50 and 25. Okay, so again, so we will at first consider for 50 and 2. Again I can see for 50 initially its parent will be 50 itself, and for 2 its parent will be 2, but 2 has higher rank. So again the 25 will 50 will be the child of 2 only, right? So this is how it will look. Similarly, if you do it for 25 also, you can see that 25 is also will point to 2 only, right? So since the rank of 2 is higher than 25, then again 2 will be our absolute parent for 25. Similarly for 5 we already have it, and again for 10 we already have it, right? So after doing the union operation for these two nodes 20 and 50, our set will look, I can find one set like this only, right? So now we will move further and I will check for 9. Okay, so for 9 I can go back to my parent array, and here I can see that at first we need to identify for 9, right? What are the divisible of 9 or divisor of 9? Okay, so 9 cannot be divisible by 2, but it can be divisible by 3, right? And absolute value of 9 is 3 only. So there should be one possible combination, that is 9 and 3. So again I will check for parent of 9. So parent of 9 is 9 itself, and parent of 3 is 3 itself. So in this case both has same rank, so we can take any of the one. So probably we can make 3 as the root node and 9 will point. Okay, cool. Now we will move further. Okay, so we are done with 9 and 3. So again so since the 3 is become my parent, right, absolute parent of 9, so its rank will become 1. So we will increase the rank 1 here. Okay, so now we will do it for 63. Okay, similarly for 63, what are the square root of 63 is it can be up to 7, right? So 2 is not a divisor, so 2 is not a possible. So but 3 can be 3 can divide 63, right? Another one, 4 cannot be, 5 cannot be, 6 cannot be, but 7 can, right? 7 into 9 is 63. Okay, so there are 4 combination again. So one will be the 63 and 3, another one will be 63 and 21, another one will be 63 and 7, another one will be 63 and 9. Okay, so we need to check for everything, every 4 combination, right? So for 63 and 3, if you check that, you can again find that parent of 63 is 63 itself, but for 3 it's 3 itself, but 3 rank is higher, so 63 will be point to 63 only, right? Similarly, if you check for 3 and 7, right, 63 and 7, right, so you can find that again 7 will be point to 3 only. Similarly, the 9 will also point to 3 only. Okay, so if you draw the diagram, again it will look like this. So we can see that there are 2 sets. One is the first one for 2, another one is for 3. These 2 are distinct sets. Okay, so now again we can run another for loop and I can check every number, right? So I will go to pick 20 and I will try to find its parent. So for 20 its parent is 2, right? So I can take one map and I can put one counter there, right? So whenever I will find similar parent, then I am going to increase my counter, since we need to consider the max value. So again then we will take for 50, and again for 50 I can see that for 50 parent is 2 itself, right? So again for counter will be +1, so that will make it 2. Again then we will go through and go forward, and we can find that next number is 9. For 9 our parent is 3, right? So we will create another entry in the map, and initially counter will be 1, and the last number is 63. Again for 63 we can find that our parent is 3, right? So again for 3 we can increment our counter and it will be 2. So then we can pick any of the maximum of these two, right? So in this case both are 2, we can pick any of the one and we can return it. Okay, so this is the algorithm. So now let's try to look at the okay, so as I already told you that we are going to use union and find. So let us implement the same quickly, then we are going to write the actual implementation. Okay, so initially I am going to take one class, so probably union and find something like this, and we are going to take two variable. One should be the parent, this will be an integer array, another one should be the int, and it should be rank, right? Now what next? So inside the constructor we are going to initialize this, right? So whenever we are going to initialize our UF class, we are going to initialize these two array, right? So we need to pass one parameter called max. So what is the maximum value? Till that we are going to consider, we are going to create the array, right, to maintain the parent and ranks. Okay, so it should be like this. This dot parent should be equals to new int and it should be max. Okay, so similarly it will be for this dot rank also. This dot rank should be equals to new and again it should be int of max, right? Now what next? So once we are done this with this, we need to populate this parent array, right? So let's populate that. Okay, so we can run one for loop. So for int I equals to 0 and again I can be greater than less than equals to max, since we are considering from 0, and so it should be always max plus 1, right? So it should be max plus 1 since we are starting from 0. Okay, now what next? And we need to increment our I and we need to update our parent value, right? So it should be parent of I and it should be I. So that means initially all the sets will be disjoint and all the nodes will don't have any parent, so it will point to itself only, right? So we are doing that only that, but rank will be initially by default 0, so we don't need to initialize that. Since it's the integer, it will be initialized to 0 only. Okay, so that will be the constructor implementation for you for our union and find class. So now let's write logic for find, right? So how we can write it? So for find we are going to return integer value, because in the find we are going to return the parent value, right? So it should be integer always, and we are going to pass the corresponding node value, so we can name it as nen or u probably. And now what else? So we need to find it, right? So we can run one while loop and we can check that if u is not equal to parent u, then we will keep trying. So suppose initially it can be nested, right? So in that example there was no nested parent. So since we are using rank, so we are going to reduce those nested parent child relationship, right? So it will be always absolute parent. So one node will be point to its absolute point, right? Not using other nodes, right? Okay, so it should be parent u, and if it is not equals to, then we are going to update it. This, right? Parent u equals to parent u, and u equal to parent u. So basically it's a common logic for find. So to the union and find, it's the common implementation of find across. Okay, and once we are done, we can return the parent, right? So you will return our parent for that particular input node. Okay, so this will be our implementation for find. So let's quickly write implementation for our union also. So in case of union, we are not going to return anything, so it should be void return type, and we are going to pass two nodes here, or two value. So one will be u, another one will be v, right? And we need to, at first what do we need to do? I need to check the parent of those corresponding node, right? So it should be pau something like this, and we are going to call our find method and we are going to pass our u value, right? So let's do that. So it should be u and it will return me the corresponding parent, right? Similarly we will do it for v also. Again it should be find v, and once we are done, we need to check that if the parent is same, then we need to do anything, right? So if pau equals to pav, then we can stop execution. Since it's already in the same group, then we don't need to do anything, right? Else what we need to check, if the rank of u, sorry, it should be pau less than rank of pav, So that means V node has or PAV has higher rank. So if it is higher rank, then that will be the parent, absolute parent of PAU, right? So it should be like this: rank of PAU equals to rank of it should be PAV, right? So we are going to update our rank, okay? And else if rank of PAU is greater than rank of PAV, in this case it will be the opposite thing, right? So it should be rank of PAV will be PAU. So PAU. So it should not be rank, it should be the parent, okay? We are updating parent. Okay, fine. And if both are equal, so if they have similar rank, then we can choose any of the one, right? So it can be anyone can be the parent, okay? So we can write like this: parent of PAU will be PAV. So you can choose any of the one, and we are going to increment the rank of PAV since it is become the parent of PAU, okay? So rank of PAV plus plus. So this will be the implementation for union. Now we will go back to our main methods, okay? So here at first we need to take one hash map, right? Obviously to maintain the to separate counts for separate disjoint sets, okay? So it should be integer. We are going to store integer value only, so both will be integer and integer. And let me name it as map only, and again we are can take the hash map implementation here. It should be hash map. Okay, so now what next? We need to find the maximum array, right? So int max should be equals to, so what we will do, we will at first take the maximum value from our given array. So we can use arrays.stream inbuilt in Java 8 method, or we can use normal for loop also to identify the maximum value, okay? So once we identify our maximum value, we are going to create instance of our UF. So let's create that. So it should be UF equals to new UF, and we are going to pass this maximum value since we can initialize the parent and rank array in the UF. And once we are done, we are going to run one for loop, and we are going to calculate this thing, right? So we are going to calculate take one node, and we are going to calculate all possible combination for that particular node, okay? So let's do that. So it should be int should be a. We can run enhance for loop, and we can pick one number of our array at a time, and then we will going to run another for loop. It should be int I should be initially it should be num. You can let me decide num only. Num should be initially start since from 2, since we are not going to consider 1 because all the numbers are divisible by 1, right? So we will going to start it from 2 only, okay? And it will run till num less than equals to. So we can use math dot square root function, square root of a, and we are going to increment num after that, okay? And once we are done with this for loop, we are going to check that if that number is really divisible. So if a percentage num equals to 0, that means its number is divisible, then we can do the union, right, for both of the combination. So it should be uf dot union, and again for initially we need to pass a and num actual number, and second time we are going to call union with the other value, right? Since we are taking square root, it should be a then a by num, okay? So once we are done, so this will prepare our this two set, right? Using union, we are just preparing our these two sets. So once we are done with this for loop, that means our these two set is ready. Now we can run another for loop, and we can count the number of nodes, maximum number of present in which set, and we are going to return that value, okay? So to do that, we need to take one variable first. It should be answer, and initially it should be 0, in which we are going to keep tracking the maximum answer value. Then again we are going to run another for loop, and again we will use enhance for loop here. Okay, so now what we need to do, again we need to at first call our find method, right? So here what we will do, we will, so suppose initially we will pass 20, and we will need to find our its parents, right? So if it is of same parents, that means it belongs to same group. If it is a different parent, then that will belong to other group, right? So we are going to call our find method here, right? So it should be uf.find, and again we are going to pass a here, right? Okay. So now once we got our parent number or parent value, we are going to put that in our map, right? So if .map.contents key m, then we are going to increment the counter. So let's do that, map.put, and we can increment it. So key will be always my m, and it should be map.get m plus 1. Okay, and if it is not there, we are going to insert in our map. So it should be map.put, and we are going to put m, and initially it will be 1. Okay, and once we are done, and we need to keep tracking the maximum one, so our ans should be math.max, and we are going to take the maximum value, either answer or the corresponding map value, right? So map.get, and it should be the m. Okay, and once we are done, we can return our answer. Okay, I think that's pretty much. Let's quickly compile our code and check. Okay, actually let us define it as public only, since we are accessing it from other class, so it should not be private. Okay, okay, I think it's giving us expected answer. So let's try to submit our answer and check whether it's accepted or not. After that, we will again do the recap, and that will give you surely much better understanding. So you can see that our solution is accepted. So let's try to understand what we are doing here. Okay, so let's try to quickly recap what we are doing. So what we have done earlier, initially we will going to take two array. One will be for storing the max value, the parent value, and another will be for rank value. Okay, so what will be array size? We will try to identify the maximum number in our input, right? So suppose if you take the second example, here our maximum number is 63. Okay, so we are going to initialize our two array of size 64, since we are starting from 0. Okay, so this is the first thing we are doing using array.stream. Now we are going to initialize our UF class with the max value. So inside the constructor we are initializing that. So initially all the nodes will be disjoint, so its parent value will be similar to that value only. So if my node is 1, then its parent will be 1 itself, right? Since all the nodes are disjoints up to 63. So that thing we are doing here using this UF constructor and this for loop. Okay, so after that we are running one for loop, and we declare also map. In this map we are going to keep track the total number of nodes for particular set. Okay, and next one is we are running for loop, and we are checking all the possible combinations. So suppose I am picking 20, so I can check that what are the numbers that can divide 20. Okay, so 2 can divide 20, 4 can divide 20, 5 can divide 20, and 10 can divide 20. Okay, so these are the possible combination, but we are taking up to max square root value, since if I consider these 2 and 4, then I can do it for other two combination, right? Because that's a divisor and remainder. So then we will check for these two condition. Then we are calling the union function, right? Union function, and we are trying to check that these two nodes are in same group or not. Okay, so if it is same, so at first we will check it for probably 20 and 2, and you can see that for 20 initially its parent is 20 itself, and for 2 also its parent is 2, and in this case we can pick any of the one as parent. So we can pick 2 as the parent probably, and 20 as its child, right? And we can increase the rank of 2 by 1. Okay, so similarly we will do for other combination, and we can see that after doing that we will get two groups, right, like this. Then we are running the another loop, and we are checking the maximum number of nodes present in which group, and we are going to return that. Okay, so this is the algorithm we are doing here using union and find. So basically all the nodes will be initially disjoint, then we will try to group those nodes using union and find. Then we are going to, using map, we are going to find the maximum number of nodes in which group, and we are going to return that as an answer. So what is the time complexity? So what will be the time complexity? The time complexity will be order of n into square root of n, right? Because we are running second for loop till the square root value. And what will be the time space complexity? So space complexity will be order of max of the max value, right? Max value of the given array, right? So max of A. So you can say order of max of A. So whatever the maximum value, in this case 63. So we are taking two array of size 63. So space complexity is order of n, then order of max A. Okay. So that's pretty much for this video. If you like this video, please subscribe to our channel. Thanks for watching. Bye bye.